Hello everyone. So the next most important topic is priority scheduling. In most of the examinations after SRTF or keeping away the SRTF and LRTF, main question that being asked is priority scheduling. So please listen carefully here. Here we'll have many new terms that going to come here. So it is also a preemption method. So here they will mention in the question that lesser number has the higher priority or higher number has the higher priority. So in this, so let's take the lesser number as the higher priority. Okay. So question and solving the problem. So you can take higher number as a higher priority also. So what is this means? See, if we take two processes, suppose two processes are coming into the ready queue, the lower number has the higher priority. That means which have the lower number in priorities? 3. So P1 will be into the ready queue. Okay, next. So here I have written another term that is context switching. Context switching is nothing but whenever we are drawing the Gantt chart, if we are starting with, for example, SP1 process, after certain multiple times the process runs, there may be a change in that process. That means P1 is getting changed into P2 or any other process. That is the context switching. Means we are changing from process 1 to another process. Okay, we'll understand it by while doing the problem. So I already told that less number as a high priority we are taking. So let's make the Gantt chart. 0. Okay. So 0 is there. At 0, is there any process coming here at the arrival time of 0? Yes. So P1 is coming. So P1. So here P1 is coming. So now, what is the next arrival time? Here, the value we are writing here is the next arrival time. So, the next arrival time is 1. So, okay, 1. We wrote 1. Now, we see that what are the processes we have in the ready queue? So, P1 is there and P2 is also is there. Okay. Now from P1 and P2, which have the lesser number in the priority. So we are seeing here. So the priority for P1 is has the lower number. So lower the number, higher the priority. Okay. So now we take again P1. And so now what is the next arrival time? 3. So we are writing here 3. So what are the process coming until the arrival time of 3? P1 is there, P2 is there and P3 is there. Compare priority numbers. Okay. In priority numbers of P1, P2, P3, lesser number has the higher priority. Already P2, P3 has the same number. So we again give the priority for the P1. So P1 is there. And now the next arrival time is 4. So again P1, P2, P3 and P4 are there. Again we'll take the arrival time of P1. So at P1, so but we'll make the again the comparison of priority. So P1, P2, P3 and P4 again we have the priority as P1. But now you can see we wrote P1 and the next priority is 5. So P1, P2, P3, P4, P5 is also there. Now up to P5, the priority number we give now is P5. Because it have the priority number as less number, so we give the more priority. So less number, high priority according to the priority number. So this is the thing we are assuming. In this question, they gave that. So at P1, the next arrival time is P5. At up to P5, the priority is low for P5. So we take P5. And now the next arrival time is P6. Up to here, P1 completed 5 units of time. Is it right? So 5 minus 0. So total times. So total 8 minus 5 is 3. So total remaining units for the P1 is 3. I hope you are understanding it. Next, so P5. So now we have again P1, P2, P3, P4, P5 and P6. Okay, now you can see what are the priority numbers. Again, we'll write P5. Okay, P5. Next, arrival time is 10. Now, P1, P2, P3, P4, P5, P6 and P7 is there. Now up to P1 to P7 which have the lower priority number because we are giving it as the higher priority. So P7, so P7 is written here and here. So 10 plus 1 is 11 because P7 is completed now. P7 has completed its burst time thing. So up to P7 it is completed. Now we have from P1 to P6 where the burst time is priority is low for P5. So now we are taking P5. 7 is arrived here. Now we have to calculate this time, right? So, so total time completed for P5. P5 we have another unit of time. Okay. So 10 minus 5 total time is 5. So 6 minus 5 is 1. So there is 1 unit of time. After that, after comparing the 10, we are getting as P7 and after comparing priorities, we return P7 and P7 time is completed. So 10 plus 1 is 11. Now we'll see the arrival times, the priorities. Which are the lower priority? P5 has the lower priority. We'll write P5 and here 11 plus 1 is 12. So P5 is also completed. Now, if P5 is completed, again which have the lower number? So 3. Now we are writing P1. So P1. So here the burst time for P1 is 3. So we'll write directly 12 plus 3 is 15. Because there are no any other numbers that are lower than its priority. So directly we'll complete the P1 process. Later again we'll calculate the priorities because once all the priorities comes in the ready queue, then we'll calculate directly the priorities. I hope you have understood this problem. We'll do another problem also, then you will get clarity. So after P1, we have the priorities of P2, P3 and P4 and P6. P2 and P3 have the same priority. Then we will see the again the arrival times. So if priority is equal, then we'll see the arrival times. So P2 is arrived first. So we'll make it as 17. Next we'll take P3, 17 plus 4 is 21. Next we'll take P4. Next P4, 21 plus 5 is 26. Okay, 21 plus 1 is 22. And P6 finally 22 plus 5 is 27. So if you add all the original burst times, you will get 27. So now you can calculate the completion time, turnaround time and waiting time. Where turnaround time is equals to completion time minus arrival time and waiting time is equals to turnaround time minus burst time. So I hope you understood this and here the context switching is also done from P1 to P5 and P5 to P7, P5 to P1 again. Okay. Okay. Now we'll see another problem, then you'll get understand. So, so this is the another problem that you'll understand now very clearly. So at 0, always we start the arrival time from the 0. Is there any process arriving at 0 time? No. So this is called as ideal time for the CPU. So now we'll write here 1 unit of time because the next arrival time is 1. So at 1, so P0 is getting occurred. So we'll write P0 and next arrival time is 2. Now in the ready queue, we have P0, P1 and P2 is also there because its arrival time is also 2. Now from P0, P1 and P2, we'll make the priority. So lesser number has the higher priority. That means now we'll write P1 as the next process. That means here there is the context switching. So that means a process, the next arrival time is P2, and at P2 we have P0, P1 and P2. Again, now we'll see the priority as there are three processes are coming up. So in this, the priority lesser number has the higher priority. So again we choose P0, and now we take next arrival time is 3. So we'll write here 3. So at 3, what are the processes are coming? P0, P1, P2 and P3 and P4 is also coming. Next, which have the lower number of the priority? P0. So that have the highest priority. So again we'll write P0 and next arrival time is P4. So P0, P1, P2, P3, P4 and P5. Okay. Now again we'll say the priority. So which have the highest priority? Which are the highest priority again? Because lesser number has the higher priority. So again we'll write here. So here you will understand that again we got, so there is no next arrival time. Here we are writing 5. Why? Because already P4, P not have the process of 4 arrival time. So its burst time is 4. So we have completed 4 minus 1, that is 3. So here we have 4 minus 3. Okay, so 4 minus 3 equal to 1. So now we again choose P naught. Its final burst time is 1. So here we are writing 4 plus 1 is 5. I hope you understood. So here whenever we got the next process P4 and we have all the processes in the ready queue like P1 to P5, then we will calculate its remaining burst times. So P4 already completed its remaining times as 4 minus 1, 3. So 3 times. So 4 minus 3 equal to 1. So the remaining burst time is 1. So next, if we calculate again the priorities, we are getting the same P0 as into the queue, as into the Gantt chart. So 4 plus 1 is 5. That means here P0 is done. Next, if you see the priorities, the next priority is for P1 and P4. They have the same priority. So they have the same priority. And then we'll see the burst times. So P1 has the lower arrival time. So we'll see P1 as here. So 5 plus its burst time is 2. That is 7. Next we'll take P4. So P4 is 7 plus 1, 8. Next, if it was completed, next we'll have P5. 8 plus 2 is 10. Next we have P2. 10 plus 3 is 13. Next we have P, what is remaining? P3 is remaining. So P3. So 13 plus 5 is 18. So here again, if you remember the previous classes that I told you, so the burst time, if you calculate, you will get here 17, but here we will get the completion time as 18. Why? Because we have here idle time where CPU is not running any processes, because we don't have any process that is coming at 0. So this way we will solve the problem of priority scheduling. I hope you understood this problem, and if you have any doubt, please comment in the comment section. And next we'll give the another last and final preemption method, that is round robin. We'll discuss it in the next video.